Okay, in this section, we're going to talk about the graph of a function. Graph of a function. So what is a graph? So a function is defined by an equation in xy. The graph of the function is a graph of the equation. What is a graph of equation? The set of points xy in the xy plane that satisfy the equation. Okay, so that's the graph. For example, when you have x plus y equal to 0, the simplest function. This is a implicit definition. Explicit definition is x equal to negative 1, y equal to negative x. Then you will see that 1, negative 1, it satisfies the equation, and 2, negative 2, it satisfies the equation, and even pi, negative pi, it satisfies the equation. So for whatever stuff you put all of them together, and that will be the graph. Okay. The first part is to identify the graphs of a function. So given you a graph of an equation, how do you know it is a graph of a function? Because function is a small class of equations. It's not all equations. So identify the graph of a function, we use a vertical line test. This is the name of the theorem, vertical line test. You will use it to cite this theorem. A set of points in the xy plane is the graph of a function if and only if every vertical line intersects the graph in at most one point. Okay, so if for every vertical line it will intersect the graph in at most one point, or we'll say, okay, this graph of equation is a graph of a function. So for example, when we have something like this, you draw the vertical line test. You draw the vertical line, it will intersect the graph at one point. Why it gives us the graph of function? Because we know that what is a function? Given one x, there's only one y, one output. Okay. Okay, so the vertical line contains, corresponds to the x. So it represents when I have one input, I will only have one output. If this x is not in the domain, of course, there's no intersection. So that's why we say at the most 1 point. Okay, so and this point x, y is on a graph. And if you have, for example, this one, you see this x has two multiple corresponding images. You have y1, you also have y2. And this violates the definition of functions. So this is not a graph of a function. One input, one output. That's a basic property about a function. Okay. Let's see more examples. If, for example, we have this one, this graph, and we just draw the vertical line, you will see that whenever you have vertical line, you will have just one intersection. So this is a graph, a function. The right one. And this could be y equal to x squared. And for this graph, you draw the vertical line, you will also have just one intersection point. So this is also the graph of some function. And this function could be y equal to x cubed. And if we have this one, and unfortunately, you see here, when we draw it, you will have two intersection points. So this is not a graph of a certain function, and this is possibly the graph of function equation, the graph of equation y squared equal to x. Remember that's the y squared equal to 4px, that parabola, the first standard position. And also if we have circles, and clearly we know that for some vertical line, the intersection has more than 1 point. So this is not a graph of a function, it's a graph of the equation. This is a graph of equations but not functions. Okay. Okay, so that's the example. Next, let's see how do we obtain information from or about the graph of a function. We're trying to obtain the information. What information a graph can give us. Obtain information from or about graphs of a function, of course. Well, let me sketch this graph here. So we have this. Okay, so this is 4, it's negative 4, it's a pi over 2, this is a pi negative 4, it's 3 pi over 2, here is a 0, 4, 0, 4, this is 2 pi 4, it's a 5 pi over 2, 3 pi negative 4, and this is a 7 pi over 2. It's a 4 pi 4. Okay, so that's yeah, the graph. We sketch the graph here. We want to obtain certain information from it. Okay, A. What are f0, f3 pi over 2, and f3 pi? Because here we have some special labeled points, so we can read it. If you choose any other points, possibly we do not have a concrete value, but those are the special labeled points, so we can clearly mention it. F0 is 4. F pi 3 pi over 2, 3 pi over 2 is here. F3 pi over 2 is equal to 0. The value corresponds to the y coordinate. Okay, so f3 pi is negative 4. So the input are x coordinate, output are y coordinate. What is the domain of f? The domain of f just means the possible values for the x, for the input. So the domain of f is from 0 to 4 pi. From 0 to 4 pi. So this is the domain of f. What is the range of f? The range is about y. You see y, it starts from negative 4, it go up to 4. So the range of f is from negative 4 to positive 4. Domain horizontal, range vertical. Okay. List the intercepts. When we say least intercept, we mean x-intercept and y-intercept. Okay, so let's check y-intercept. If you have a function, then there's only one, at most one y-intercept. For a function, there is at most one y-intercept. For an equation, you can have multiple y-intercept. Okay, so let's write here. Function can have at most one y-intercept, because y-intercept is f0. f0 has only one value, but the equation can have multiple y-intercept. It can have a multiple y-intercept. For example, the circle will the circle has two y-intercept. The circle has two y-intercept. Okay, so here we have an equation. We have a function, so there's only one y-intercept, f0. f0 is 4. This is a y-intercept. X-intercepts. X-intercepts. You can have many x-intercepts. X-intercepts are the intersection point of a graph and the x-axis. So you have pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. So pi over 2, 3 pi over 2, 5 pi over 2, and 7 pi over So these are the x-intercepts. Question E. How many times does the line y equal to 2 intersect the graph? While y equal to 2, where's y equal to 2 is here. Y equal to 2 is a horizontal line, so you just draw the horizontal line. Get a dotted line, you check the intersection point. You have a 1, 2, 3, 4, okay? 4 times. That's it. You don't have to explain it, you just observe it from the graph. For what value of x does fx equal -4? Equal -4, where? Here, pi, 3 pi. 1x is pi, is -4. 1x is 3 pi, is -4. Other part, well, either from the graph, they are not as low as -4. Second, there's no other point labeled. So, for x equal to pi, 3 pi, fx equals -4. Okay? Just direct observation. The final thing, G. For what values of x is fx greater than 0? Fx greater than 0, the y value is above the x-axis, right? The y value is above x-axis. So you check the graph. This piece, the middle piece, and the right piece, those pieces are above the x-axis. So 0, pi over 2, 3 pi over 2, 5 pi over 2, union 7 pi over 2, 4 pi, fx is greater than 0. That's it. There's no further discussion because you just read it from the, observe it from the graph. Okay, so that's what we say. We obtain information from or about the graph of an equation. You have a graph, you can try to read as much information as you can, and also it depends on the graph. If the graph is very precise, then you can read more information. If the graph is very sketchy, then you possibly cannot be able to read a lot of information. Okay. Okay. Next example. We try to obtain information about the graph of function. About a graph of function means that one is from the graph. You have the graph, you get the information. About the graph of function, basically, we want to know which point is on the graph, which point is not on the graph. Okay. Consider the function fx is equal to x plus 1, x plus 2. This function. Find the first two questions. Find the domain. have the denominator, just make denominator non-zero. That's the domain. So x plus 2 is not equal to 0. X is not equal to negative 2. So the domain of f is equal to, let's see, negative infinity, negative 2, union negative 2, positive infinity. By this union, we just remove the negative 2. Okay? Or you can write this way. The set of all real x such that x is not equal to negative 2. Either way, it depends on your depending on yourself, which formula you use. Second question, is the point 1/1/2 on the graph of f? We're trying to determine if this given point is on the graph or not. Well, let's check if it satisfies the equation. So basically the equation is like this. The equation, when we talk about the equation, we will use y to replace fx. So y is equal to x plus 1 over x plus 2. For x equal to 1, y equal to 1/2, let's check. X equal to 1, 1 plus 1 is 2. 1 plus 2 is 3. The right side is this, but left side is 1/2. Not equal. So it means this pair does not satisfy. This pair does not satisfy the equation. So the point 1/1/2 is not on the graph of f. Okay, it's not the right one. It's not a point. Part C. If x equal to 2, what is fx? What point is on the graph of f? What point is on the graph of f? X is 2, just plug in. F of 2 is 2 plus 1 over 2 plus 2 is 3 over 4. This is a y value. So the point 2, 3 over 4 is on the graph of f. So this point is on the graph of f. Part D. If fx is equal to 2, not x equal to, fx is equal to 2. What is x? What is x? And what point is on the graph? What point is on the graph? Fx is 2. Well, put here. Fx is x plus 1, x plus 2. You let it be number 2. Then we solve this equation. We multiply two sides by the denominator. And we simplify it. Move 2x to the left side, 1 to the right side. It's x minus 2x. 4 minus 1, and negative x is equal to 3. So x is equal to negative 3. X is negative 3. X is negative 3. Its corresponding value is a y. So the point negative 3, 2 is on the graph of f. It is on the graph of f. Okay, those are the special, the general point, like 2, 3, 4, whatever value. Whenever you have a, this is output. You have output, you can find the input. This is the input, you find output. Um, there are other point with geometric meaning. What the x-intercepts. What are the x-intercepts? What points are on the graphs? Above. Okay. So x-intercept, fx is 0. X-intercept just means fx is equal to 0. So x plus 1 over x plus 2 is 0. A rational expression is 0 if and only if the numerator is 0. So x plus 1 is equal to 0. X is equal to negative 1. So when x is negative 1, this expression is equal to 0. So the point negative 1, 0 is on the graph of f. Okay, so that's the information about the graph of a function when you have the expression of function. Okay, let's see another example. It's a word problem. The average cost C bar of manufacturing X computers per day is given by the function C bar of x is equal to 0.56 x squared minus 34.39 x plus 1212.57 and plus 20,000 over x, whatever. That's just a function. This is average cost. So determine the average cost of manufacturing A 30 computers per day. Here, this x represents the number of the computer manufactured per day. So when you have 30 computers per day, just basically say x equal to 30. X equal to 30, you compute C bar of 30. First of all, this problem is designed by using calculator. Okay, so with those numbers, you must use calculator to get a precise, estimation. So you plug in that, you get 0.56 times 30 squared minus 34.39 times 30 and plus 1212.57 plus 20,000 over 30. With the help of the calculator, it's about 1351.54. Be careful, this is estimated, because we use cents as a minimum money, so it's up to 54. And in the exam, if you have some problem, those numbers will be carefully chosen so that you can do it by hand. Again, in the exam, you cannot use calculator. So it looks like this. And the question asks you what is the value for 40 computers per day, and you will have C bar of 40. It depends on the calculator. So you just let X be 40, you just write this again. And part C, you have 50 computers per day. You will see that you must have a calculator, otherwise you will spend the whole day to compute it. So let me write it. That's 40 square minus 34.39 times 40 plus 1212.57 minus plus 2000 over 40, and it's approximated by $1,000 and 232.97. And you have 50, you can do the same computation. I really don't want to write down that expressions. And D, you see here, D, use calculator, well, advanced calculator, to graph the function C bar for x between 0 and 80. X between 0 and 80. Even though this problem, x represents the number of the computers, basically x can only be the integers, the natural numbers, 1, 2, 3, 4, 5. X cannot be 1/2. We don't have 1/2 computers or pi computers. But when you use calculator to graph it, the graph will be a continuous function, will be a continuous curve. So in the textbook, it gives the graph. The graph looks like this. So it means sometimes at a certain moment, we can read it. At a certain moment, the average cost is the smallest. The lowest means the average cost is smallest. So what is the purpose of this graph? We are trying to figure out at which point, for what kind of x, the average cost is smallest. So you see here, this one, when you compute when you manufacture 30 computers, the cost is this. When you manufacture 40 computers, the cost is this. When you manufacture 50 computers, let me give you the estimation. It's 1293.07. So it's increasing. It's bigger. This one is bigger. This one is bigger. This one is smaller. So after some test, you will say that for this manufacturing company, it's better to compute to work out 40 computers per day, because the cost is smaller. Okay. So that's it's not about the graph, but you can apply the graph to the real life. Okay. And if you want more precise value, you have to use calculator to list the table, like x is 1, x is 2, x is 3, up to x is 80, and from that you can figure out the minimum cost, the cheapest cost. Okay, so that's about the graph of function. Graph x, y satisfy y equal to fx. And vertical line test, whenever you have a curve, you need to determine if that curve is a graph of a certain function or not. Okay, so this is the basic concept section. There's no tricky computation problem, just direct verification. Point on the graph, off the graph. Make sure you understand the concept. That's the most important thing. Okay, we stop this video and we will start next video to discuss the properties of functions. Thank you.